The other day, Bob kind of strong-armed me a little bit. He said, how about a presentation on the current state of satellites? And I've got to tell you up front, I don't know, or I didn't know much about satellites at all. I mean, I observed some contacts and things like that, but anyway, said, yeah, I'll look into that and see what's happening today, you know, and so forth. And the more I dug into it, the more interesting it got. And I kept going down all these little rabbit holes, and I mean, there's just oceans of information out there. Well, anyway, I'm not going to tell you how to set up a station today. That's another discussion for somebody that's more qualified than I am. But I do have a little bit of history, and then what's actually happening today. And I found a couple of things, projects, if you will, that I think you guys might enjoy. So we'll share that. If we consider a little history, I remember when I was a kid watching Sputnik go by and listening to that. That was Sputnik talking back. Anyway.
Sounds like Russian.
Yeah. That was October 5th, 1957. Had a downlink of 20 megahertz and 40 megahertz, and I remember hearing it on 20 megahertz. Well, just a little bit later, Explorer 1 was the United States' first satellite, and that led to the detection and mapping of the Van Allen radiation belts, which was kind of neat. When they got it up there, the radiation from the Van Allen belts kind of overwhelmed the sensors. They didn't know what to make of it at first, and so that was really kind of interesting. It's a whole story in itself. A couple of years later, the first weather satellite launched. It was 270 pounds, carried 2 cameras and a video recorder. Now, guys, in 1960, a video recorder was a monster. And it was only able to record like 32 frames, and then it sent it back. But that was the first images we got, and that operated for a total of 78 days. Then it was kaput. And then the next thing I remember watching in the sky was Echo 1. And that was nothing more than a big balloon. And I remember President Eisenhower gave a very short little speech, which was beamed off of Echo 1. But mostly I remember watching it cross from back porch at the house. The telemetry came down at 107.9 megahertz. It's an FM station today.
Yeah.
But powered by 5 NiCad batteries and 70 solar cells, which was pretty advanced for its day. And the total thing weighed 150 pounds.
Wait a minute, if it was a passive satellite, I thought it was just a reflector.
It was, but it had some telemetry to let it know that, you know, it inflated and that sort of thing.
Nothing to do with any bounced signals.
Yes.
No.
Well, not in the bounce signals.
No. Okay.
It was strictly a reflector, and I've got a picture of it here in just a second. Sputnik was kind of interesting. It was 23 inches in diameter, so a big beach ball, 184 pounds, and it had 3 silver zinc batteries that weighed 112 pounds. So those batteries kept Sputnik going for 22 days, and it was actually filled with nitrogen, which was kind of interesting. Now Explorer was a much smaller affair. It was 6 inches in diameter, and the total length of this is the actual satellite part, and this is a booster part. This whole business here was 80 inches, and this front part was 37 inches. And it orbited with the booster stage attached, because the booster stage had sensors on the outside of it. Anyway, it had a 60 milliwatt transmitter at 108.03 megahertz, and that lasted for 31 days, and then a 10 milliwatt transmitter at 108 megahertz that lasted 105 days, and it had a whopping 29 transistors, the electronics.
Wow.
Mercury batteries were 40% of the weight. So, but that was our first one.
Well, how high up were some of those?
They were in low Earth orbit, all of them in low Earth orbit.
Yeah.
This is artist's conception of the first weather satellite, and then this is the actual image that came back. It was not the highest grade resolution. We'll see some from the current crop of weather satellites, which are very high resolution. Here's Echo 1. I remember seeing this as a kid. They actually inflated the thing, 100-foot diameter, and then this is how they sent it up. It's all folded up in its little container, and when it got out, while it needed a lot of air to inflate it on the ground, it only needed just a little tiny bit to inflate it up in space.
Sure.
And then this was a new one to me, but there was something called the Project Westford. Somebody got the idea that if you released millions of tiny, like little antennas, and we're talking antennas that are only about 18 millimeters long, that you could bounce signals off of it. And so they sent the satellite up with 480 million of these needle-like antennae, and while it ejected the needles, they didn't disperse, so they basically ended up orbiting, and they're still up there, some of them, in little clumps. Well, then they tried it a little bit later. It was successful, and it did work, but it needed beaucoup power to bounce anything off of it. But they thought if they encircled the globe with these little needles, that they would have, you know, the ability to bounce signals back and forth. Well, anyway, the needles that got dispersed quickly decayed and, you know, fell back, but that was abandoned. And this gives you, I don't know if you can see it, but these are like the needles in comparison to a stamp. And this is a needle on one of somebody's finger, and artist's rendition of the satellite that actually did it. Kind of weird, right? But that was the beginning of the space race. Well, you would think that, you know, it would have taken a while for the, the first ham radio satellite, but Oscar 1 was launched on December 12th, 1961. 10 pounds with a 140 milliwatt beacon, and it transmitted HI in code at a speed that was controlled by the internal temperature of the satellite. And more than 570 hams sent in reports they'd received it. And it was the first satellite to reach orbit as an auxiliary package, and the ejection mechanism, you can Google this, but anyway, is built around a spring they got from Sears. So it was really high tech. Anyway, that orbited for 22 days before re-entering, and they learned a lot of stuff from that first Oscar. And Oscar 2, 3, and 4, they followed quickly on the heels, and they discovered that they didn't need as much output power, and so they got a little bit longer life out of the satellite and things like that. There's a picture of Oscar 1. So it just had a little whip antenna, 10 pounds. And the stripes were purposely applied to help regulate temperature. So that was the reason behind that. Well, today we have all kinds of satellites up there. And they kind of categorize them by mass. So you got these humongous ones, and of course the International Space Station, that's the biggest one. But for our purposes, we're going to be looking at some microsatellites and some nanosatellites as it pertains to ham operations. And these are surprisingly small and yet very effective. And there's a couple of terms that we should probably clarify too. One is AMSATs, and these are satellites that are non-commercial, non-governmental. They're built by generally schools, or in some cases clubs, and they have at least one scientific experiment on board. Now the telemetry to control and receive data from the satellite may or may not use ham frequencies. A lot of them do. A hamsat is similar to an AMSAT, but it carries a transponder or repeater that we can use to communicate with. In most cases, an AMSAT and a hamsat are one and the same. But that is a distinction that they do make. So while an AMSAT may use ham radio frequencies, it may not necessarily contain a repeater or transponder that we can use. Now what kind of devices are there up there that we can use? Well, there's the FM mode, and that's where you uplink on one frequency and downlink on another, and we've seen that demonstrated. Dave Kent gave us a demonstration a couple of years back using a handheld unit. And then there are linear transponders. Now, a linear transponder can do sideband and CW and also a number of digital modes. The digital modes, however, are limited to those that take up 3 kilohertz or less. And then there are digital transponders, they use basically packet radio, AX25. The one thing to note about the digital transponders is the signal comes up, it gets decoded, and then sent back down clean as a whistle, right? So a linear transponder, you get noise up, you get noise down. Digital transponder, you can have noise and data up, but just data down, because it gets reconstituted. Now, right now, it seems that all digital transponders are limited to APRS, which basically that's your location, and then you can add a message to that. Now, the majority of the satellites that are ham orientated are these new CubeSat satellites. And they're built to a dimension of 1, which is 10 by 10 by 10 centimeters. So that's small, right? That's a, 10 centimeters, that's like 4 inches. And so you can have multiple units of 10 by 10 by 10. And here I'm showing you can have 1 unit, 2 unit, 3 units, but in actuality you'll see you can have 1.5 units, 1.75 units, etc. And the typical weight is about 3 pounds per unit. So this is showing some different configurations. Here would be like a 1 unit. This would be like a 2 unit, 2.5 unit, etc. And they can get larger, but almost all the ones that are associated with what we would be communicating with are somewhere between 1 and 3 units in size. Now here's an actual single unit CubeSat, and you can see it in comparison to the guy's hands there. So that's pretty cool. And here's one where they stack 2 together. Now I wondered, well, this is cool because they're talking, well, we can release, dozens of these out at a time, or sometimes they just chuck them out of the International Space Station. How do they get them orientated? They call that attitude adjustment. Well, they don't have motors like, maybe what we're accustomed to seeing. But what they do have is they have these wheels that kind of give torque, and they have these magneto-torquer rods. And that's how they can get the satellite to, point in the right direction.
Using inertia.
Yeah. So I thought that was pretty cool. Somebody was thinking when they thought of that. That's how they do it. And all of that mounts on a board, as we'll see, that is part of the CubeSat sandwich. Now, some years ago, AMSAT in the UK said, let's put some satellites up there and let's give them a dual purpose. So there are these things called fun cubes, and they're CubeSat satellites. And during the weekday, they're for educational purposes. The weekend and in the evening, they are amateur satellite transponders. There's currently 6 of them up there, and it requires what they call a FunCube dongle if you want to receive all the educational stuff. And this is actually an SDR dongle that you can use for all sorts of stuff, but it has a very sharp front end to it with SAW filters and all of that good stuff. So it's a real high-end unit, 125 pounds and whatever that translates into our money. Anyway, there's here's the link for it, and if you go to funcube.org.uk, they have a dashboard which you can download, and then it allows you to do whatever, decode whatever's coming down from it. Well, if you thought the CubeSats were small, how about a sun cube? Now these are 3 centimeter square cubes, and you can see, from the picture, they're small. And 27 of them can be launched into space for 1 CubeSat. So there's a bunch of these things floating around up there. None of them, however, are accessible for us as hams. There's no transponders associated with them. And then there are what they call tube satellites. And these things, about 9 centimeters diameter and almost 13 high, you can see in comparison how large or small they can be. And they're about 0.75 kilograms. Again, none of these are up there with ham radio stuff on it. But it's kind of neat to see what's up there, Well, what is currently available to us? Well, there are the FM repeater satellites, and we'll post this on the website. But anyway, if you clicked on this here, we would see all the information associated with this particular satellite. And so these are the FM repeater satellites currently available, and as far as I can see, they're all in polar orbit, and more about that in a minute. The transponder satellites that allow single sideband CW, there's quite a few of these up there, and we're going to look at these last 2 in particular. This last one is the only geostationary satellite available for hams. Unfortunately, not to us here in the United States. I'll explain that more in a bit. The digital satellites, basically these are all APRS. This one here does do PSK, and the International Space Station has got a digital repeater going on all the time as well, and there's an interesting website I'll show you here in a minute that you can go and see your signal if you beam it up there. This is couple of three websites you can go to for active satellite information, ham satellite information, as well as tracking information. And so, but this, we'll post the PowerPoint on the website and you'll be able to click on these. And then, this is kind of neat. See if we can get this one to come up. This oops. This. I think I have to do that. Jeremy, why isn't this?
Change your projector mode.
Huh?
Or is PowerPoint taking over, or do you just have to change your mirroring mode?
PowerPoint is ruling. Huh. Just a second. I know how to. There we go. All right. Anyway, so these are all the stations currently being reported by the International Space Station. So I don't know. That's kind of cool. And then. This site is all the rest of the digital satellites that are repeating the APRS information. So you got the International Space Station and then everybody else, all the other digital satellites.
You got to those maps by what, the find you address, or URL, I mean?
I'm sorry?
And how did you get to that map? By using that third link there?
Right, yeah,
Find
this
you?
one. Yeah,
Okay.
this one. And this one here.
Oh,
The one thing I didn't realize was orbit time, you know, I mean, how does that figure in? I should remember this from physics class, but I didn't. Anyway, how long it takes for a satellite to orbit is based on Kepler's 3 laws and of planetary motion, but I won't get into that. But bottom line is there's basically 3 orbits involved. There's low Earth orbit, and that's from 160 to 2,000 kilometers, and that takes between 90 minutes to 2 hours. 55% of all satellites are in low Earth orbit. Medium Earth orbit is at about 20,000 kilometers, and that takes about 12 hours to circle. And by the way, there aren't that many satellites in medium Earth orbit, but the GPS rather, the GPS satellites are. And the GPS satellites have an orbit period of 12 hours. And then there's the geosynchronous orbits, and they're at 35,786 kilometers, and they have an orbit of 1 day, and that's why they appear to stay put in the sky. And the reason that they're almost all at the equator is because that's where the Earth is the roundest, and they can get the most stability. 35% of the satellites up there are in geosynchronous orbit. So when we talk about low Earth orbits, most of them are in polar orbit, which means that they're the satellite goes around the Earth between the poles, and then the Earth turns underneath it, and that means then that every spot on the Earth gets covered. And most of the ham satellites are in this polar orbit and have a orbit time of about 90 minutes. Now, there are two types of weather satellites, which we'll get into, but they're in sun synchronous orbits, and that's a polar type orbit, except that sun synchronous means that they cross the same spot every day at the same time, but they also have to change about 1 degree a day to get this accomplished. And these satellites orbit at about 700 to 800 kilometers. And these weather satellites in sun synchronous orbit are the ones that we can easily receive. This is showing the medium Earth orbit, and that's at about 22,000 miles up, and takes about 12 hours. Almost all of them are set to exactly 12 hours. And then geosynchronous, and this helps us appreciate that we get to see basically about half of the Earth at a time. Now, if you're into wanting to see the satellites actually pass overhead, the best time to do it's right after sunset, when you are in the dark, but the satellite is still in sunshine, and that allows us to see it streak across. Now, the low Earth orbiting satellites, which includes the International Space Station and some medium Earth orbiting satellites, can be seen, but the geosynchronous ones require a telescope, and they're still pretty faint, so it would take some skill to see it. This is kind of a neat website, Spot the Station, and let me bring that up. Why does it always work at home? When you
Have you connected with the Wi-Fi here?
there we go. All right. Let's try this one more time before we. There we go. Anyway, this particular website allows you to figure out when the space station's gonna pass overhead, and it's pretty intuitive. Plus, they got a lot of neat stuff there, if that's, you know, if that's your ball of wax. Now, weather satellites, I found this really interesting. There's two kinds. You've got these geostationary ones, and then you've got the ones that are in polar orbit, sun-synchronous polar orbit, and they output FM signals at 137 megahertz. And so some of us probably have receivers that can receive this. They output pretty neat pictures. These are two examples right here. This one's over Scandinavia, this one's over the southern US. And they're quite detailed. So these are images that you can receive relatively easily. You need to have a good antenna though. And you can try one of these quadrifilar helix antennas cut for 137 megahertz, or the easier turnstile antenna. They both seem to work quite well, and they're available commercially, or you can build them. The images that you'll receive are called APT, Automatic Picture Transmission, and they have a resolution of about 4 kilometers. So that's not too bad. High resolution pictures are available at 1.7 gigahertz. That's going to be a little more challenging to receive. And then there are both low and high rate for the geostationary satellites. And the FunCube and Hack RF dongles are reported to work well receiving these signals. If you want to buy a package with everything, you can do that. There's a place in Denmark that is selling these, and it's a little box and a turnstile antenna, and it looks like it probably take you about an hour or two to set the whole thing up, you know. The only thing that you need to do is mount the antenna and run the wire. These are very interesting websites to explore for weather information, if that's kind of your bag. And I know, you know, some of you guys are into the Skywarn and so forth. So anyway, moving on, this is something that's been in the news just recently. Elon Musk with his Starlink satellites, right? Put in orbit by SpaceX. This is a picture of what it would look like up there. But now imagine that the FCC gave approval in April of last year to place 12,000 of these in 3 orbital shells to provide internet service. Each one of these weighs about 500 pounds, so it's a big boy. And 60 satellites can be launched at one time. So if you Google this, you can see where there's a video showing the SpaceX deploying 60 of these Starlink satellites. And this is a picture of how they look like 60 satellites going across the sky at night. So you can imagine that the astronomers are up in arms over this. And can you imagine, 10, 12,000 of them up there? Anyway, so whilst I was looking at all of this good stuff, I came across a site that I thought you guys would enjoy, and I'll just show that to you. So if you're interested in citizen science, right, there's all sorts of things you can get involved with that don't require a big outlay of money or just a little of your time, basically. And this group is kind of heading up a NASA project. NASA wants people to take pictures of these satellite trails and submit them, because this is all part of trying, it's really messing around with the telescopes on Earth, trying to get pictures, and there's all kinds of things, pictures you can see. And then this is the actual site for doing that, and it's the Satellite Streak Watcher. And this whole SpaceX Elon Musk deal kind of really got it going.
So those are visible without a telescope?
Very visible. Yes, yes, very visible.
Are they up there already?
There's quite a few up there, yeah. I think there's well over 100 now.
Oh.
And
that becomes pollution.
pardon?
It's like sky pollution.
Yeah. Yeah, so
The previous generation of that, the Iridium satellites, the first generation of those, as they orbit, will flash. They'll catch the sun and you'll see a flash. And apparently the favorite thing for techie types is to take a Boy Scout troop and make a story up and say, there, and all of a sudden it flashes. And apparently it's quite visible.
yes. Yes, I ran across a number of videolets of that. And
Okay.
yeah, so anyway, so this whole Starlink thing, it's kind of interesting, and the goal is to provide internet service to every corner of the Earth. And I don't really have an opinion on it, other than I can see where the astronomers would be really not happy. But
Iridium just about went bankrupt. They were actually deorbiting satellites and shutting down the company when the government stepped in because they needed satellite phones. And the government gave them enough money to continue to go. And now I think they're in a little better shape. But there for a while, they were actually deorbiting satellites.
They can bring them down and let them burn up.
Yeah. Yeah, they were taking them out of orbit because they were basically going to fold the company.
Wow. So there's no, competition with nobody else that does it?
I'm not sure about that, but I think they're back above the water line there. Yeah, but the government needed satellite phones for, you know, all of their embassies and everything all over the world, and so that money, that's the rumor anyways, that's what kept Iridium afloat, and now they've got a second generation of satellites up.
There were 2 or 3 different satellite competitors, but they use different technologies with like different coverage techniques, or areas. And so it may have been that Iridium was one that had served different needs that were important or something.
Okay, could be.
This idea of, putting a globe around the globe of these satellites for, widespread internet service. Okay, just knowing that, it sounds like a great idea, to provide internet service to anybody anywhere. But how much gear would a person need on a computer to be able to connect to one of those satellites?
Well, good question. The only thing I know of in comparison is the current internet satellite service, which basically requires a TV-sized dish.
Oh.
But the data rate is not that high. It's about like DSL. So.
Yeah, that's HughesNet, and they're a derivative of DirecTV.
Yeah.
Oh.
Well, this one here, Husky One, was just recently deployed, and it's from the University of Washington, and it's 3 CubeSat units, so it's about that tall. And they've got 3 experiments on it. One is a plasma thruster, which is kind of cool. I'll show that to you in a second. Another is a K-band communication system, and another is a camera provided by a high school in Washington. Now, in addition, it will have, but is not active just yet, a 30 kilohertz wide linear transponder, and here are the uplink and downlink frequencies, as well as the telemetry frequencies. So that will be available, and should be pretty cool. It should be available here in the next couple of months. This is showing how the Husky One is assembled. So you've got your camera down here, your power amplifier and antennas, and then here is your attitude board right here with it has both. So this has the magneto torque assemblies, and this guy here has the wheels. And then back here is one of their experiments, which is actually going to be a thruster. This is showing the satellite on a workbench with the panels deployed, and that's your artist's conception of it, with a motor. And this is the first CubeSat that I'm aware of that's got a motor. And it's a sulfur fuel cell that's ignited by high voltage. And this business right here is about the size of a votive candle. And this is a picture of it ignited. So that's kind of a neat thing. I'll be interested to see. I don't know, I couldn't determine if they fired the thing or not. So more to come on that. And our last ham satellite is this one put up by the Qatar Satellite Company. Went up November 15th of 2018, and it was built in Japan by Mitsubishi. It's the first amateur geostationary satellite. Here are the uplink and downlink frequencies, and I'm going to show you this analog devices thing that they're recommending for communicating with it. Unfortunately for us, however, it's geostationary over this part of the world.
Yeah.
So if you're in the Middle East or Western Europe or Africa, you can use it, but there's only a little bit, like I think it's like a Nova Scotia, tip of Nova Scotia, that it hits in North America. But it's a big satellite, and it's mostly for commercial communications. But it's got the ham radio transponder on it. Now, this is neat though, and it might appeal to some of you. They're recommending that as the core of your receiver transmitter, you buy this transceiver from Analog Devices. DigiKey sells it for $142. And anyway, look at the RF coverage on it. And it's got one transmitter and one receiver. Can do half or full duplex. It's got a USB interface. It's just pretty cool, and that's what you get for $142. And this is kind of a block diagram of it. And I don't know, I might have to get one of those. And finally, this is almost a who cares, but it's weird. It was called OuterNet at first, and now it's called OtherNet. And basically, there are 3 geostationary satellites, commercial satellites, that cover North America and Europe. And in North America, we have a 20 kilobaud download rate, and in Europe, they have a 10 kilobaud download rate. And it streams internet data, an audio channel, and ham APRS. And so that's why I included it, because you can send a message, APRS message. It will, if it has OtherNet in the message, it gets picked up and sent up to the bird, and then comes down and is part of this data stream. And you wonder, well, what do they data stream? Well, they data stream Wikipedia and news articles. And I suppose if you lived in some remote part of the earth, you might find this interesting, but not so much for us.
So why the different baud rates between here and Europe?
Different satellites.
Oh,
Yeah, but in either case, you need one of their Dreamcatcher data boards, and you can get this whole setup, which is the board and the LNB, and that's all you need. You just need to point this towards the satellite, and $69 US.
So the APRS data that it's streaming is not direct from our APRS transmitter.
Correct.
And so you still have to be at range of a APRS repeater.
Correct. And the only way it'll get up there is if you have OtherNet in the message.
Okay.
And that's picked off, and then that's sent up to the bird. How, I don't know, but it's got to be through, their commercial, and then it comes back down.
Okay. So it's useless as an emergency locator.
Yes, correct.
That's what I was trying to.
Correct. In fact, the whole system to me is kind of who cares, but it was so weird. I mean, I thought it was weird anyway. I thought I'd include it. And then finally, well, I sent those 2 books around. And then, as mentioned, ARRL just announced yesterday, as far as I'm aware, this new book. Steve Ford, I think, wrote it. He's a pretty good author. And it appears to be like, if you were wanting to get into it, that might be a book to get. I was kind of curious if I wanted to order from DX Engineering all the stuff to set it up, you know, the radio, the Yagi antennas, the two-way rotor, all of that, you know, plus the low loss coax, and I came up to around four grand, you know, which I suppose, if you know, compared to a Harley, is nothing. But I don't think my wife's gonna let me do that. But I do intend to put a weather satellite up, weather satellite receiver system up, because I think I can mount a turnstile on my deck, and that might be kind of fun.
So when that weather satellite signal comes down, you get this big picture, and the U.S. is covered with clouds. How do you tell where you are? Is it the software you use?
Okay, so you hook this up to your, to your radio, and then the radio goes to your computer, which is running some freeware, which you get from NOAA.
Okay.
And so you just, once you've got it set up and working and receiving, when the satellite comes over, you get the data, your computer processes it, and you can see the pictures. And it comes over about every 90 minutes.
I think there's an overlay with like latitude and longitude.
Okay, so
So
that's
you-
enough to tell where
Yeah,
you're at.
so even if it's completely cloud covered, you can say, well, there's Detroit, there's whatever.
Well, and the satellite will kind of put the map over. Well, you can overlay the map on top of the image.
Okay, but the satellite itself doesn't transmit the map.
Correct.
Okay.
Yeah, the satellite just sends the picture, and then the software on your computer does the rest. And again, it's freeware. So basically what you need to do is make an antenna, get a dongle that'll receive 137 megahertz, and don't forget that that's probably going to be 75 ohm impedance versus 50.
Oh,
So you use like RG6, and then download the free software, and you're good to go. So guys, that's all I got. Thanks.
Thank you.
Good job, Steve.
yeah.
Yeah, good presentation.